So take out your highlighter and highlight factored form. And factored form is really nice because if you have something that can be factored, and we can use, I'll use the example that was right at the beginning. You had y, or you just had, I'll put a y in there, but you had at the beginning the 3x squared minus 9x minus 30. 3x squared minus 9x minus 30. And I could factor out the 3, leaving me with x squared minus 3x minus 10. And then I could factor this completely to be minus 5 and plus 2. And when it's in factored form makes it really easy to find x-intercepts. Because algebraically, we find an x-intercept by plugging in 0 for y. And if it's already in factored form, and you plug in 0 for y, this becomes a chapter 3 question, right? When we did quadratic equations. You solve quadratic equations by making one side 0 and factoring, so you can use the zero product property. And the zero product property says, if you're multiplying things together and the answer is 0, something has to be 0. That's the only way you can multiply and get 0. Can 3 be 0? Absolutely not. 3 is 3. Can x minus 5 be 0? Yeah, if x was equal to 5, then that would be 0. Could this one ever be 0? Yeah, when x is equal to minus 2, it could be 0. And what that tells us on the graph is it tells us that we're going to have an x-intercept at minus 2 and an x-intercept at 5. So if you were asked to graph 3x squared minus 9x minus 30, you would have the x-intercepts. You would also know that it opens up. So it has to look like this. If it looks like that, halfway between 5 and negative 2, which is 1.5, that would be your axis of symmetry. And then you would know on your green graph that your vertex is at 1.5 comma something. And you now have two ways of finding your vertex. If you know your axis of symmetry, you know the x-coordinate of your vertex, then you could just plug in 1.5. It's not the easiest or nicest mental math to do, but you could plug in 1.5 for x and determine what the y value would be. And then you'd find your vertex that way. So if we look at the diagram that I showed you at the beginning, we now have from our general form, sometimes, not always, but sometimes we can write it in factored form. If you have it in factored form, you can find your x-intercept. If you have your x-intercept, the average of your x-intercepts finds your axis of symmetry. Then you could find your vertex by plugging in that x-coordinate. So now we have a new way to find our vertex. Right? But some of these arrows seem to only go one way. Like, if you have your axis of symmetry, you can't get your x-intercepts just knowing your axis of symmetry. You don't know how far apart they would be. So this is the factored form. The factored form is nice for finding x-intercepts. It can also then find your axis of symmetry, and that could find your vertex. So that could also be helpful. And usually, if you find your vertex, you already know your a value. You could use your a value and your vertex to write the standard form. So you could go backwards even there. Maybe I add an arrow to the original diagram there. Right, so they talk about this with the axis of symmetry here. And maybe this is at the top, or sorry, yeah, top of page 302. Might be worth highlighting. The constant term highlight this too. We've done this before. Right, so the equation of the axis of symmetry is always the average well, you don't have the diagram. Oh yeah, you do. It's on the page before. That if you just take the average of your two x-intercepts, you get your axis of symmetry, and then that can help you find your vertex. So let's go to example 1. Identify the intercepts, the equation of the axis of symmetry, and the coordinates of the vertex of this equation. Okay? So we have choice. Let's list everything here that they asked us to find. They asked us to find x-intercepts, y-intercept, axis of symmetry, and the vertex. Okay? And if we think about that diagram that we looked at the beginning, we're starting here with the general form. The things that we want to find: y-intercept, x-intercepts, axis of symmetry, and the vertex. Those are the things that they asked us to find. Okay? Y-intercept would be the thing I would find first. It's the easiest right off the general form. So if I go to this, go back to our question. If I'm doing this as what's the easiest thing to do first, y-intercept, I plug in 0 for x. Super easy to find that one first. The rest of the things are not easy from the general form. So now I have a choice. Do I change things to my standard form and spend time doing that? Or do I change things to factored form and spend time doing that? Or will I have to do both? Sometimes you might have to do both. Okay? So then, looking at our diagram again, I want to find x-intercepts. The x-intercepts are only available through the factored form. So I know for sure I have to do the factored form. And if I do that, I can find my axis of symmetry and find my vertex. It looks like I could skip standard form here altogether. So let's see if this can be factored. Sometimes things can be factored, sometimes they can't. So we'll go back to our question. And based on what we wanted, it seems like the factored form makes sense. So can I take out a common factor? Can I take out the negative 2.5? Well, that would leave me with x squared. How many negative 2.5s are there in 7.5? 3 of them. How many negative 2.5s in 10? 4 of them. Make sure your signs are correct. Right? If I took a negative 2.5 out of a negative 7.5, I get a positive. If I take a negative 2.5 out of a positive 10, I'm going to get a negative. This is really nice because now inside here, it's a pretty easy one to factor. It's going to be x. If it can be factored, it's going to be x and x. 4. The last one's a 4. Either 2 and 2 or 4 and 1. But it needs to make a 3 with your outside and inside. See that the 2 and 2 is not going to work to make a 3. So I'm going to go with 4 and 1. Now we have to decide, is it plus 4 and minus 1 or vice versa? Well, I need a plus 3 as my middle term, so I need plus 4 and minus 1x to make that work. And then to find my x-intercepts, I put in y is 0. So x-intercepts are minus 4 comma 0 and 1 comma 0. Axis of symmetry. I could get my axis of symmetry from my vertex, or I can get my axis of symmetry from the average of my x-intercepts. Well, I don't have my vertex yet, so I could complete the square to get my vertex, or I could get my axis of symmetry from the average of my x-intercepts. So if I take my average of x, it's going to be x equals, my two x-intercepts are -4 plus 1 divided by 2. So my axis of symmetry will be -3/2. Which I now know that my vertex is going to be -3/2, comma, something. Okay? Again, I could find my vertex by completing the square, or since I already know the x-coordinate of my vertex, I could plug it in. I could plug it in for x either here, or I could decide maybe I want to plug it in the factored form. It's up to you which is going to be easier mental math for you to do. I'll do them both and you can decide, okay? First of all, life is going to be easier with fractions rather than decimals. So I'm going to do this one first, this one second, and you decide which mental math you like better. So finding my vertex by plugging it into the first one. I would change -2.5 to a fraction, -5/2. Then I'd plug in -3/2 squared minus 7.5 is 15/2 multiplied by -3/2 plus 10. Order of operations. Square first, so this becomes 9/4.
Excuse the interruption, but could all the students that are in the Beyond the Borders Culture Club please come to the office for a moment? All the students from Beyond the Borders Culture Club, please come to the office. Thank you.
-45/8. I guess I'm going to need a common denominator for doing all of these, so I'm going to change this 45/4 to 90/8, and this 10 to 80/8. And that will come out to 125/8. Do they have that as a decimal or at the bottom of the page? They do. Because I guess they were assuming maybe you'd use a calculator. Double check, and it is the same number. That's option 1. If you did option 2, plugging it into the factored form, -5/2, you'd still change that to a fraction, and then you'd plug in -3/2 plus 4, and -3/2 minus 1. Order of operations, do your brackets first. So here I would need a common denominator. My common denominator would be, change that to 8/2. This will become 5/2. Here I change that one to 2/2, -5/2. Multiply the tops. 5 times 5 times 5 is 125. 2 negatives would make it positive. Multiply the bottoms. 2 times 2 times 2, 8. Then we get the same y coordinate. So you make a decision. If you're plugging in a fraction, most of the time people like to plug things into an original equation. So that's often a good strategy. I think the original equation made us do a little bit more complicated arithmetic. I think the factored form was a little bit easier to do the arithmetic. But you would get to decide. Either way, we find the y coordinate of our vertex to be 125/8. Boy, grade 11 doesn't worry about fractions anymore. Like sometimes grade 9, teachers would be like, ooh, we're not going to do the fractions might make it harder, so we'll just avoid them to make your life easier. A little bit of that in grade 10, but then moving forward, it's sort of like, okay, you need to know your fractions. You can't sugarcoat it anymore. They're going to come up in questions. Just going to have to work with them. Questions for practice, circle 3, 4, and 5.